Hi guys. So today we're going to transition from log equations to exponential equations. Now logs are not going to go away, we're actually still going to use them, but we're going to look at equations where your variable's in the exponent instead. So we're going to look at a couple different forms of these types of questions. The first two on there are the two that we actually don't need a calculator for to find the actual definitive answer. A lot of these that we're going to solve today, your answer is going to be left in terms of log, or in terms of ln, or in terms of e, or in terms of something else. We're not going to get the exact decimal answer unless we use a calculator. But these first two, it's actually possible to find it without doing it that way. So what we can do, if you notice 3 and the square root of 3, they're pretty similar because they can be rewritten with the same base. So the square root of 3, that's the same thing as 3 to the 1/2 power. So what I can do is I can rewrite the square root of 3 as 3 to the 1/2 power. Well, then I know based off my exponent properties, a power to a power you multiply. And if you have the same bases, then all you need to do is solve the exponents. So I have x minus 1 equals 1/2 x plus 1/2. So 1/2 x is equal to 1 1/2, or 3 over 2x. So x equals 3. Now with questions like this, what's really important is that you rewrite these numbers with a different base. What you'll notice, a lot of people, what they want to do is they want to just square root this. Okay, you can't square root a single number like that. That changes your problem entirely. It's no longer an equivalent equation. By rewriting this, the square root of 3 and 3 to the 1/2, that is the same thing. I have not changed this equation in any way. If I just square root something, I have to do it to every term. So I can't just square root this. I would have to also square root this. And then it's not going to help me because I still have bases that aren't the same. So again, just be careful on these to rewrite them in terms of the same base. All right, so again, looking at the next one. 1 over 9 and 27 can both be rewritten in terms of the same base. They can both be written with a base of 3. So this is why it's really helpful for you guys to be familiar with your exponent properties. So 1 over 9 is the same thing as 3 to the negative second. 27 is the same thing as 3 to the third. So again, all I did was rewrite those numbers in terms of the same base. So now, using your properties, you can multiply those exponents. And now, since the bases are the same, I just need to make those exponents equal. And I get my answer. All right, so now let's look at a couple that are a little bit different. So these are ones that we are not going to be able to rewrite in terms of the same base. So what we want to do here, if it's possible, is get the exponent base by itself. So on this first one, I'm going to get 2 to the x by itself by subtracting 1. At this point, I can just rewrite this as a log. So this would be log base 2 of 14 is equal to x. Now, if I want the exact answer here, at this point, I would use a calculator. But if this was non-calculator, I would leave my answer as log base 2 of 14. And that's my exact non-rounded, non-decimal answer. And sometimes we prefer to have that exact answer versus the rounded one the calculator is going to give us. All right, again, moving on to this one. Our goal is to get this base by itself. So the first thing I would do is add 2. Then I can divide by 3. And now that the exponent base is by itself, I can rewrite this as a log. Well, this would be log base e. But remember, we don't write log e. Instead of log e, we write ln. So this would be ln of 3 equals x over 3. Well, at this point, the last step to get x by itself is to multiply both sides by 3. And you're done. All right, so now what we're going to do is look at some that can get a little bit messier, because now we have 2 bases that both have exponents. Now, there's a lot of different ways that you can work this out. I'm going to show you guys 2 different methods. You can pick whichever one you think is easier, but there's a lot of different ways to actually write a correct answer to this and still have it exact and in terms of log, and it just might look different. So what I'm going to do here is, instead of rewriting this as log base 2 of 3 to the x minus 1, I'm going to take the log of both sides. Okay, so you know how like we can square both sides, we can add 3 to both sides. I'm going to go ahead and just take the log of both sides. Now the reason I want to do this is because, using my properties, if this is the log of 2 to the x, that exponent can now move to the front in both cases. So this becomes x log 2. X minus 1 is going to move to the front. Now remember, when it moves to the front, it's being multiplied by that log. Now one of the things we talked about when we did properties was you cannot distribute to an argument. All right, so we can distribute here. The reason for that is that's actually being multiplied. It's not part of the argument. So if I have the log of x minus 3, I cannot say that that's log x minus log 3. Okay, I cannot distribute to an argument. But if I have something like this is different because it's actually the quantity of x minus 1 times the quantity of log 3. So we can go ahead and distribute. And that's actually what we're going to do. Because what we want to do here is actually very similar to what we did when we were doing inverses for rationals. What we want is everything that has an x to be on one side, and everything that doesn't have an x to be on the other side. The reason we want to do that is because now I can factor out that x in order to get it by itself. So that x comes out, and now I can divide by what's with it. Now, like I said, there are a lot of different ways that you can write a correct answer here. If you want, you can rewrite this as log of 2/3. You don't have to, but it's the same thing. You could rewrite the top as log of 1/3, because that's technically 3 to the negative 1, because of that negative out in front. But again, you don't have to do that, okay? There's a lot of different ways you could write these answers equivalent. But this, if you were to plug that in a calculator, is going to give you the decimal answer that works for x. But this answer that we have right here, we like that because it's exact. It's not rounded, and it tells us exactly what that answer is. Now, like I said, there's actually more than one way to do this problem. So what you also could do, I'll write this one over here on the side in purple, is I could go ahead and write this as log base 2 of what's on the other side of the equal sign equals the exponent, because 2 to the x is equal to 3 to the x minus 1. And it's going to work a similar way. Okay, the x minus 1 is still going to move to the front. I'm still going to distribute. I'm going to get everything with an x on one side. I'm going to factor out that x. And then I'm going to divide. And what I get here, even though it looks different, is the exact same thing. If you were to plug both of those into a calculator, you're going to get the same decimal. It's just a different way of writing it. It's just a different format. So whichever method makes more sense to you and is easier, go ahead and do it that way. But again, we're finding just that exact answer, whichever method you choose to use. All right, so looking at example 6, very similar, but we'll just, again, you can do it either way. I'm going to go ahead and take the log of both sides just because that's the way I've just done it more often. And this way is actually nice in case for some reason you have a calculator that doesn't allow you to change the log base. So we're going to move that exponent to the front. Remember, it's being multiplied, so I am going to put it in parentheses. I'm going to go ahead and distribute. I'm going to move everything with an x to one side. Factor out the x. And divide by what's with it. And again, like I said, there's a lot of different ways. If you want to condense these using log properties, you're welcome to do that, but you don't need to, because at this point, this is an exact answer. It tells us what that value is. If I want the decimal, I can plug this into a calculator at that point, and I haven't rounded anywhere within this problem, which is why we kind of like doing it this way. All right, so the last one that we're going to look at may look a little bit difficult, but actually is a pretty easy factoring question. So one of the things that we've talked about this year is sometimes with factoring, you kind of want to replace with something else to make it easier to see. So what we typically said, or what I typically use is the letter U. The reason I use the letter U is because it's not X. Okay, so we know it's not what we're solving for, and I just use U because that's what you'll use in your future math classes. So if I replace something with U to make this easier to factor, it's going to make this problem a little bit easier to work out. So what I'm going to replace U with is e to the x. Because if I do that, then e to the 2x becomes, remember, e to the 2x is e to the x squared, because you multiply those values. So this becomes u squared minus u minus 6. Well, that's really easy to factor. That factors into u minus 3 and u plus 2. Well, then, to solve for u is 3 and u is negative 2. But again, we don't really care what u stands for in this problem. What we still want to know, we still need to know what x is. So at this point, I need to go and plug this back in. So I get e to the x is equal to 3, and e to the x is equal to negative 2. So at this point, to solve this exponential equation, I can rewrite this as a log. Now, I'm not going to do, again, log base e of 3. Okay, that is what we're doing, but again, we don't write log base e. This would be ln of 3 is equal to x, and ln of negative 2 is equal to x. Well, without even evaluating this with a calculator, we can tell there's an extraneous solution, because the natural log of negative 2 isn't going to happen. You can't take the log of a negative number. So my only solution here is the natural log of 3. Again, at this point, if you want that decimal, you can go ahead and get a calculator and plug it in, but that's it. All right, so that is not your to-do list. I apologize. That was an old video. So this is your correct to-do list. But again, very similar. You got your practice problems. Check your answers, show your work. If you need any help, jump in that Zoom session, email me, or do that video request. And then by Friday, you've got that week 6 assessment, which will also have log equations in it. Again, if you have any questions, feel free to let me know.